So the recording won't include part of my intro, but we'll be fine with that. So anyways, we'll get going and continue. I'm Ashley Williams. If you haven't met me before, I'm the Chief Operating Officer for TEMA, and I oversee curriculum, education, development, virtual chapter, and stuff like that, a bunch of random things. So as you guys are sitting there watching the meeting, try to avoid all the distractions that might be around you, and don't leave too soon because we will have the discussion at the end. And a lot of the times I feel that's the biggest value that we bring with these virtual meetings, is that you're able to connect with people across the state and see what's going on with them and learn from each other. And also, this is on Zoom. You have two options. You can submit questions through the chat, or you can go off mute and ask your question. Just try to be polite if you do that. I will mute you on if there's some background noise that I can hear. I will go ahead and mute you though, unless you're actually asking your question. I wouldn't do that. So just, you know, we all know this virtual stuff by now, but don't hesitate to ask any questions. We have some exciting news to share. We are opening up registration for our conference in September on June 1st. So next week, everybody be ready to register for our conference. We have a lot of very jam-packed schedule, and I'm gonna play this video for you guys so that you can, it can tell you everything and you don't have to listen to me the whole time. Sorry, I was trying to respond in the chat box, and apparently I cannot do that without stopping the video. So we will be starting at 8:30 on Wednesday morning, and we will go till 12 o'clock on Friday afternoon. So we are very excited about all of it. We have, like it said, 40 plus breakout sessions, and we have the virtual option, so it will be hybrid. And so we'll have several options for you to watch virtually, and sponsorships will be opening up. Everything will be opening up on June 1st. So if you guys have any questions in the meantime, please reach out to myself or Cami, and we can answer your questions. If you're a speaker, I'm really the person for you to reach out to. If you're a vendor and interested in sponsoring, and or you have some registration questions, that's really Cami you need to reach out to, but I can always take a stab at it. Anyways, so we also, during conference, we do our Resource Manager Awards. Those nominations are currently open. We don't have very many entries right now. So if you are wanting to nominate someone for Project of the Year, Program of the Year, Partner of the Year, or Resource Manager of the Year, go to the website, and on the rotators at the top of the website, you can click this option, which will take you to the Google form to fill out and submit your nomination. Those are due June 30th. So if you have any questions about that, please let me know. Also, a lot of people like to send us pictures of where they take their TEMA swag. It's sometimes quite comical. So if you want to go ahead, and we came up with this little game for the summer. If you take your Team of Swag somewhere and it's interesting and it's fun and you want to share it with everybody on our social media pages, and we're going to select the best picture of who wins a free conference registration. So you can use the hashtag Team of Summer, and we use Facebook, Twitter, and LinkedIn. So wherever you want to share that, if you want to try to win a free conference registration, go ahead and participate. Membership incentives. We're going to announce winners at the end of this meeting for some conference registrations, those who have renewed their membership. This year already, we've been putting you into a drawing. And so we have 2 winners to announce at the, I don't want to know where you take your cup all the time, Glenn, but we would like to know, we have winners to announce at the end of this meeting. But if you renew your membership, you will be entered into that drawing. Also, if you don't know about our referral program, you get points for referring people. So when they sign up, they will say, so-and-so told me to join. You get credits for that, and you could possibly get a free membership. We have several people who haven't paid for memberships in years because they referred so many people. So keep that in mind, and if you have any questions, just let us know. Seco still has their NOFA out, and I shared this last time, but there is a link, and I will share it in the chat box in a little bit. During the presentation for today, I'll share it in the chat box. But there is some measures that you can do that you could qualify through the Seco program. The TEMA Education Guide, we are continuing to do courses. We only have one left for the virtual side, but we'll be offering all of our courses at conference, except for the sustainability that will be virtual in the fall as well. They have gone over quite well. And so it might be the virtual world, but you still get to participate, and you still get to earn your PDHs, and you still get to learn and network with people. So they've worked out well. Like I said, we have our controls to June 8th through 9th. And then tomorrow and Friday, we will be doing our online ATEM exam. So if you thought you were signed up and you haven't heard from me about the ATEM, you need to contact me because I've been communicating. So also, come this summer, July, we're going to try to roll out, I'm really excited about this, some workshops, virtual workshops that you will walk away with something in your hand that you've done. They're more application labs is what I'm calling them. And it gives you a way to know how to do it instead of just being given a lot of information. We want you to walk away with an item that you can use at your organization. We're going to probably do a mock project throughout the series of workshops. So the focus in July will be data analytics and benchmarking, and then how to use that data to develop projects and how to share that information so a layperson can understand what they're looking at. If you're ever wondering what's going on with TEMA, we do have the calendar on the website, so go check that out. And now for what you guys all came for, not to listen to me, but what you all came for is the presentation from Real Term Energy and BrainBox. So at this time, I am going to throw it over to Mark. Mark, I'll stop sharing my screen. I guess as we're doing this, are there any questions for me from conference or anything like that? We are super excited. So we have a lot of great breakout sessions planned this year. So
awesome. Thank you, Ashley. Yeah, we're very excited too. I think it's going to be a good conference. So yeah, I think Waco's an awesome place, and I know y'all have a lot of good stuff planned. So speaking of fun, I know a lot of you on this call we're actually at the TEMA spring event. And so some of what's going to be in our presentation is, going to be a little refresher, but we did include, some new elements in it as well. So a lot of you know me from either the Clay Shoot, from past TEMA events, from being your former SCORE City Smart program consultant or from recent, communications. But for those of you who do not know me, my name's Megan Friesa. I'm the U.S. South Sales Director for Real Term Energy. With me, I have Mr. Mark Carter. He's our VP of Smart Solutions. And he's going to be going over the, kind of inception, where we are at now, and then the future of artificial intelligence. And then also, last but not least, we have Mr. Mr. Ross Lampy. He's going to be talking about how, artificial intelligence can help you reduce energy consumption and also keep your buildings more comfortable. So without further ado, I'll go ahead and pass it over to Mr. Mark to get us started. Mark, over to you.
Thanks, Megan. So we just put together a brief agenda, and as Megan mentioned, we'll start with kind of why this matters, right? The importance of reducing energy usage for HVAC equipment, and then we'll spend a little bit of time with the fundamentals of AI, kind of going back into the history, how it's classified and categorized, and then I'll turn it over to Ross, and he'll cover the use of artificial intelligence in building HVAC applications, and also provide some information on a case study. So first, we'll discuss why it matters, right? And certainly global warming is not a new topic, and it's really the capture of solar radiation that's not allowed back out in space. And really what's considered the greatest contributor to that is the burning of fossil fuels to generate electricity. And if you look at and extrapolate back to that and look at US energy consumption, it's, the three largest components are transportation, industry, and buildings. And then within the buildings category, HVAC is by far the largest. So probably the single largest target globally to help reduce greenhouse gases is HVAC optimization. And why isn't it done more frequently? Of course, everybody is working on it, but it is the largest contributor or the largest consumer of electricity in a building. So it's generally half. Lighting tends to come in second, although there's been great advancements with LED technology. So a lot of buildings have already converted and lessened their lighting loads. And then you have some fixed loads and plug loads that contribute as well. But overwhelmingly, HVAC is the major contributor from an energy consumption standpoint. And we know based on lots of studies that a great amount of that energy is used inefficiently and wasted. And above and beyond just from a ecological or economic standpoint, there's also a tremendous amount of legislation that's coming both at local levels, state levels, and federal levels, and a lot of support and technology is being fed toward that. So, there will be ongoing pressures, I think, to make your buildings more energy efficient from a legislation and regulation standpoint. So with that backdrop, we'll talk a little bit about artificial intelligence because it is talked broadly. You'll hear artificial intelligence in almost every aspect of life nowadays, from chatbots to in the movies and such. But there really is a lot of different ways you can classify it, and I think it is helpful to understand what the basic premises are. So first, artificial intelligence really just the ability of any computer or machine to do a human-like activity from an intelligence standpoint. And that's really kind of the core definition of it. And if we look at the history, this actually goes back to Pascal in the 1600s, but really it's commonly believed and accepted that it was really during World War II when Warren McCulloch and Walter Pitts really came up with the concept of artificial neuron and how that could be used to excite the energy from neighboring neurons to actually create a brain-like intelligence with computers. Of course, back then, there wasn't the computer processing power to actually bring AI into actual development. But from a conceptual standpoint, that's exactly where it started. And if you go through the years, the term AI wasn't officially kind of dubbed until there was a conference at Dartmouth University. And that's where John McCarthy and Marvin Minsky and the RAND Corporation helped sponsor that. And it was John McCarthy that first kind of dubbed the term AI. And that was in the and that was in the mid-50s. If you go fast forward, there's a lot of technologies and advancements. One of the things I didn't really consider, and if you look back and think about it, I guess Roomba is the iRobot is a type of artificial intelligence. It goes off by itself, it avoids objects, does its task, and then returns back to its home for charging. So one of the funner, more interesting ones. But the one that I think really put AI on the map was back in '97 when IBM's Deep Blue beat Garry Kasparov, who was a grandmaster of chess at the time, and it was really a big statement at the time for the advancement of artificial intelligence. And fast forward today, you'll find many universities have courses, and it's widely taught, and a number of companies are incorporating AI as part of their technologies. So from a classification standpoint, you can kind of break it up both in capabilities as well as functionalities. So capabilities is typically you have a narrow AI and general AI and super AI, but I think most people look at it from a functionality standpoint. And from a functionality standpoint, AI is broken up into 4 different types. And the first one is purely reactive, and that's really the most basic form and kind of the intro level AI. And what that allows you to do is actually program a machine to do a specific task. So it's very rules based, and you're programming it to do something specific. So if you want to go back and look at the Deep Blue example, that all it can do is play chess. And it's very limited in its capabilities. It doesn't learn from past chess matches or future ones. It doesn't think about future ones. It's only in the now and present. It looks at the moves and it calculates the next best move. And that's all it can do. So the type 1, really came into the 1990s, and it's very limited in its capabilities. Where we generally are today, where most artificial intelligence is in the type 2. And that's where you have some limited memory. So it's not just what you're programmed to do, but you can also start to learn from past experience. So you have a memory. So you can look at what happened the last time I did that, learn from it, and make a better decision the next time. And that's where we get into autonomous vehicles. You get like the SpaceX rockets docking themselves to the International Space Station without any human intervention, right? So even at this level, you're able to do some very complex things with high processing rates. And there's different levels within type 2 that we'll talk about, but that's generally where we are today. The next phase and what we're going to see moving forward, and it's generally appreciated that it may be over the next 20 years that we'll start to see some development in type 3. And that's the theory of mind. Because what type 2 does not allow you to do is for machines to actually be able to understand and interpret human emotions and incorporate that into their decision-making process, right? So they can actually only know what the words were said and not the intention of the words, whether or not somebody was yelling, were they mad, angry, sad. That's going to be the next generation evolution of AI technology. And with the processing power as it's going now, it'll be at or above the human brain capacity of roughly 10 billion neurons. So that's going to allow a whole new field of technology in the medical markets and analysis and programming. And the last is a type 4, and that's the one you see and hear the most about in the movies, the Ex Machinas, the Terminators, and that's when the machine actually can not only interpret emotions, but is self-aware enough to have emotions. And that is where, the general hope is it'll start to make its own decisions based on its own self-interest, and hopefully humankind is involved in those. So, but those are the 4 types of functional breakouts of artificial intelligence. One of the thing to discuss is that artificial intelligence is a bit of an umbrella term. So a lot of people will lump AI, and there's many different types of AI. And again, general artificial intelligence could be any, could be a type 1 Deep Blue. So kind of really rules based. It can only do what it's programmed to do. And it's really kind of a glorified program per se. Where you start getting into more sophisticated AI is when you get into machine learning, and ultimately you want to get into the deep learning, right? That's when you're actually using memory modules to actually improve the decision-making capabilities. So it's actually training themselves. So that's where deep neural networks get in. And it's very important because AI may be shown in a lot of places, but really the deep learning is where you're going to get the maximum benefit from the technology. And speaking about machine learning, even within that, there's tons of different classifications. The three general classifications are unsupervised learning, supervised learning, and there's reinforcement learning. But again, if you don't believe AI is touching your life today, you can see everything from fraud detection, banks when you get the text messages if a purchase doesn't look right, to image classifications, to gaming, to skill acquisition. So AI is being used broadly in all different fields of technology and products. And then if we want to go one more deeper into the deep learning, you'll find there's generally two different types of deep learning neural networks, convolutional networks and recurrent networks. And the difference between the two is you'll find that convolutional networks are very good at image processing, right? So looking or scanning x-rays in the medical field, or actually doing image classification for, even self-driving cars to be able to distinguish between a person, a bicyclist, an animal. That's where convolutional networks are best suited. But the ones that will generally be talked about, especially today in HVAC, is you need to actually look at time series type events. And that's where recurrent neural networks play best. And that could be, voice processing, chat bots, where, over time, the actual environment is going to change and it has to adapt to that. It's not static like an X-ray image might be. It's much more fluid. So anyways, with that, that's generally kind of the background of artificial intelligence. And now I'm going to turn it over to Ross Lampe to talk about how this artificial intelligence is used in the HVAC industry. Ross?
Thanks, Mark. Howdy, everybody. Ross Lampe with BrainBox here. So let's go to the next slide. We're going to talk about the HVA system as it exists today and how you can apply AI to it, much like AI has been, like Mark mentioned, adapted to the self-driving car to improve onto it. And so rather than operating today, which is a purely reactive to thermal events that have already occurred in the various zones of the building, is to shift that approach to where AI, you could layer it on top and able to predict temperatures that haven't happened yet before it happens. So the big example would be, you've got your existing system, you've got all these data points, but your system doesn't know what the weather is now, or it doesn't know what it's going to be later. It doesn't know what the cloud coverage is. It doesn't know moisture, UV. Well, let's add some data to it. Let's also add utility rates and tariffs, demand structure, because the BMS right now is not aware of what times of day have peak demand, where you have higher charges if you have them. So if you're adding weather, you're adding utility. And then what about adding occupancy data? Add that, and then have the ability to have the AI be trained to understand how your facility operates with all these conditions together combined to be able to make a decision that's not reactive, but it's preemptive, proactive before you get to the event, before it gets too hot and we have to start cooling. So the goal is to take the AI, artificial intelligence, and be able to adapt it to the existing model that exists today. And then have that AI be able to control and implement decisions back into the system on a real-time basis, constantly checking everything. So it's no longer theory, it's things that are happening, but it's very exciting to be able to say, hey, my existing system's okay, I can add to it. And improve upon it to do things that we haven't been able to do for the last 15, 20 years. We've done it the same way for so long, and it's okay. let's evolve it and add a layer to it. Let's go to the next slide, Mark. And this is an example of what the zone temperature was and what the AI would think that that temperature was before the event happened. Because in order to do something like this, to have AI involved in your buildings, you'd want its accuracy rating over 99%. You'd want it to, when it's making its decisions based off what's going on outside the building and how the inside the building reacts, you want it to be very accurate so that when it does say, hey, if I reduce the fan speed here, and if I do this here, 3 hours from now, when we get to this time, I'm using the least amount of energy and I'm improving on the comfort level. So this is an example of you'd want to make sure that there was metrics that can control this and have, when it's not as accurate, where it would back off and learn, because AI has to be trained. And this is just showing that the deep learning model is good. It's providing accurate future zone temperatures and then evaluating that its accuracy from what it thought and what it was. Go to the next one, Mark. So I mentioned the reactive and the preemptive. So reactive now is you've got your cooling set points and heating, your min and max, and you're going to get to a part in time, and the BMS is going to go, hey, it's getting kind of warm. We now to start cooling because now we're getting beyond the dead band that we want to be in. And so now you're overcooling. The same thing happens when you get to the heating, or it's too cold, we need to start heating. So that's the reactive. Right now, the HVAC system reacts, or it has basic rules that are kind of estimates of we think this. If you add AI into the equation, the AI is going to go, hey, I can see at a future date and time, we're going to need to start cooling because it's going to be, we're going to exceed our cooling set points. So if I do something an hour and a half beforehand, I can make sure that we're not having these huge swings, and I can stay within the comfort, the dead band longer, but I can also do it through its decision-making and understanding in the best possible scenario of what equipment affects what and what's more expensive than others, stay within the comfort level longer, but reduce it. And in order for that to have an impact like this, you want to be doing it often. So we're using the example, every 5 minutes, ping everything, ingest all the data. What does it know? What has it learned? And take everything that it knows so that you're not having these huge expensive swings. And this is a good example of that, of optimizing it before the events happen. So this is the preemptive, predictive. The other thing with AI on the HVAC side is you need to have rules. You don't want the AI to change your zone temperature set points. You want it to operate within those as rules. And you want it to be improving on, not sacrificing on comfort. You know, the only time you'd want it to interact would be when it can affect comfort in a positive manner and reduce energy consumption and make sure that you're not spending more than you need to, which is your demand and your peak power, your tariffs. And you also want the AI to not just turn equipment on and off, because that is not healthy for the equipment, but you want to have some boundaries for it. And this is what we're showing here, that it's not just being cut loose. There's a lot of parameters that are set in place when you'd want AI and when you bring it into the equation, that that rules as it makes its decisions. You can go to the next one. Here's a case study. We'll show you a little sample. The smaller area, but it was a 30,000 square foot controlled area. And it was a typical Monday through Friday, 8 to 5. This specific example, it was a 32% reduction when AI was introduced to, and allowing it to learn and then interact and send overrides back to at the equipment level, as well as improve the comfort. And this is just really exciting. This is one of the earlier projects that we've looked at. But I say this to everybody, how many of y'all, I mean, I've not met someone who has not received a hot or cold complaint. Imagine adding AI to your facility and just cutting those hot and cold complaints in half right off the bat. That's an exciting thing. I mean, financially, but when you get a hot or cold complaint, now you have to stop what you're doing. You have to go find out what's going on. You have to go make decisions. It creates a chain of events. Whereas when you add AI to a system and integrate it, you're mitigating and reducing those events from happening. So there's a correlation between that as well. Let's go on the next one. So what does this matter in Texas? The school district's massive market, and we can take that data, add intelligence and predictive capabilities to it. It doesn't exist in the system now. It's got smart features, but it doesn't have the predictive manner. So you're not having to go, when you talk about AI and improving it, you don't want to have to go replace everything. So it's something that you could just add to what's existing. The other thing when you do have AI, you've got greater visibility. There's no new software because the AI looks like another operator within the system. You'd want the AI to also stay away from life safety. So you'd have it right back to a lower priority on the BACnet side. It also, because it studies patterns, you'd have a better ability to predict for premature failures. I mentioned a reduction in equipment runtimes, and you're saving on the kilowatt consumptions. And the inefficiency, not inefficient, but improving the efficiencies with the engineering staff. So now, instead of engineering, when you bring AI in to help out, share some of this workload, it allows them to get through other things and not have to drop what they're doing and be interrupted in the day for an emergency. And they know that if there is an issue, before it becomes a big issue, you could have the AI system notify the team. So we're seeing here on hypothetical, if you were to introduce AI in Texas, in the Texas weather in a K through 12 or higher education situation is per 1 million square feet, it's about $100,000 to $128,000 annually reduction in energy spend. That fluctuates depending on the if you're deregulated, depending on how your power's coming in, but that's what we're seeing on this type of facility. So that's the potentials behind it. What we got next? We got anything else? Oh, yes. Let's play this one real quick.
Buildings are the core of the vibrant cities we live in. However, they are the largest consumers of energy on our planet. We must do our part to make them more efficient, more sustainable, more optimized. Using the most advanced artificial intelligence technology, buildings around the world can now tackle one of their greatest challenges: the inefficient energy usage of heating, ventilation, and air conditioning systems. Brainbox AI is an industry-defining technology powered by AI that connects rapidly and securely to autonomously learn your building's unique characteristics, leveraging both internal and external data sources. Predicting the future thermal behavior of each zone in the building with over 99% accuracy, and making continuous adjustments to each component of your entire HVAC system. Brainbox AI improves occupant comfort by 60% based on your defined set point, while reducing building energy consumption by up to 25%, and carbon footprint by 20 to 40%. Intelligent building journey starts now. Join the revolution.
So yeah, we wanted to show this because it's more than just when you talk about AI in the schools, it's more than just a financial and comfort play. There's a larger impact behind it, which is the climate change, the reducing the carbon footprint, the greenhouse gas emissions, right? And so this is us talking about Brainbox right now. In the last 23 months, we've scaled to 110 million square feet globally, which I know that's a small piece when you look at the footprint, but we're reducing 20 to 40% carbon footprint on that size of a portfolio. So as this is becoming more of the forefront of everybody, I think we're going to talk about in the breakouts about sustainability goals. You know, where we sit on our end, and I brought some of my colleagues with me, is we're curious of what you guys are working on and what y'all are doing and where you want to be. We do qualify our buildings and our schools. You know, not everything's a fit, but when there is a fit, we like to talk about it. Deploying, the other thing about what we're talking about is We didn't want our customers to have to spend a bunch of money and replace equipment. We wanted it to be very easy to deploy. We wanted them to retain control of their system, not have to learn a new tool, and be cash flow positive within 30 to 60 days of deploying. So that was our biggest deal was, hey, we don't need to help change. You've got a system that works. Let's just add to it in a simple, in a small way that has a huge impact. So I'm going to pause here because I think Ashley's going to do the, if there's any questions. I know there's some of you, and gold star if you can beat Glenn to be the first person to ask a question.
Does anybody but Glenn have a question? Oh, he already put it in. Yes, we'll take questions from the greater group right now. If you guys have any that you think everybody would benefit from, if you have more specific questions, maybe for you, you can ask those within the smaller groups, but whatever you feel comfortable doing. So Glenn's question is, can you give an example of how you can predict equipment failure?
I will start this, and then I've got Blake and I probably Josh here, but I'll probably go Blake stab first. So it's not saying, hey, it's going to fail, but an example would be the AI studies patterns, and it's every 5 minutes, it's pinging everything. And let's say it's been going for 4 months and everything's been running smooth. And for whatever reason now, something's changed. And I'm not saying a window's open and we can't maintain temperature, but maybe some pieces of equipment now are not generating the results that they have been able to generate. And that would send a flag to us of, hey, Glenn, could you and Israel, could someone go look at this? We think this VAV box in classroom zone B, something's going on. Like, it's not saying it's going to fail, but it's going to give us an idea, a flag that we're going to reach out to you to go, could you go look at this? It's still operating, but we're not able to generate the results. And we've been looking at the weather, and that's not the factor. So it's eliminating those. And this is where I punt the ball to Blake and let him pick up where I've kind of started a little tangled explanation.
Ross, you did a good job. I think you hit it spot on. I mean, there's obvious things that are going to happen in an HVAC system. Sensor is going to go bad. Your damper is going to get stuck. Your fan motor can go out. So those aren't really what we're talking about. Those are pretty easy to flag. It's just more of the anomalies that we don't understand what's happening in that piece of equipment. We still want to flag it because we might not want to pull in that data for that piece of equipment anymore and change our model to mitigate this. So we actually disengage the AI portion on that piece of equipment if we're trying to control it, and then we flag it and we say, hey, Mr. Customer, Mr. and Mrs. Customer, you should go take a look at that. We're not sure what it is, but something's wrong.
I like this next question. That's a great answer. But Samuel, you're not switching from DDC. You're adding AI to it.
Yeah, we have to have DDC in place, right?
Mm-hmm.
So we need a backnet system or tritium system. We need DDC so that we can control it. We can't control pneumatics. We can't control things that we can't see digitally.
Yeah, I mean, we're talking hard. If you do require hardware, we're talking, this is it. There's a power cord and an Ethernet cable. The horsepower is cloud computing through secure connection. This is just the middleman that has access to the points, but it sends it to the cloud and asks for the cloud, what would you like me to do every 5 minutes? But this initiates connection. Our cloud can never reach down into the BMS on its own. This has to initiate the connection. So we don't need to go deep into the weeds on the security side, but the DDC question, we like that. That's a requirement. We need that. So this is added next to your front end.
And that's a key point, Ross. So, since we are doing this from the cloud, we have to have a system in place to disable what we're doing. So that's our edge device that Ross showed. It's basically just a disable function. Releases all the points under control, and it goes back to original system design. So since we're not reprogramming the current control system, we're not, replacing it. We're just supplementing it with additional layer of intelligence. But that layer still needs to be there in case for a failure.
So what specifically did the AI do to reduce electricity by 32% in 30,000 square foot building? It did a lot. That's one example. So I'll use this one example. There's another facility where we had similar numbers. It was a little bit larger. where the AI, it was in a colder climate. They had six pieces of equipment for heating for the entire facility, and they were always running. They were fired up in the morning to get started through the AI's ingestion and learning. And the engineers called us kind of concerned because they're like, hey, 4 pieces of equipment aren't running. They're not coming online. The AI figured out I can heat this whole building with just 2 of the 6. And it's more cost effective to do it this way. So it's doing a lot of things on these buildings. It's depending on what the system is. It could be controlling airflow. It could be, if it has chill water temperature, it could, within, we set rules within each customer. It's finding ways. Think of it as a strategy beforehand. And it's like, you want to kind of jump in here. It's not as simple as saying it did this, because it did a lot of things on checking, because it only intervenes when it sees an opportunity. So it's not changing things every 5 minutes. It's only intervening when it can say, I can improve the comfort and reduce the cost if I do all these things before I get to whatever is going to happen 2 hours from now or 3 hours. Because you think about it, we're sleeping at overnight. The AI is looking at the weather, what's coming. So before you even show up to your building, the AI is already knowing, hey, come 8 o'clock, they will, my customer wants this in this zone. I need to do these things because the clouds are going to be here this morning, but then it's going to get hot. So if I do it, it's always thinking ahead of time. So it's way ahead of where we look at it now. Is like, oh, I got here, I need to do this. So the rule-based, it's not really rule-based. It's more complex than just saying it did one task.
Well, yeah, I mean, I think Ross, you touched on quite a few points, right? So there are traditional energy saving strategies in commercial HVAC systems that are today. There's lots of them. I've implemented them all in every type of building. We utilize those type of strategies as well, but we enhance them with the predictive nature of the AI. And then also, when we are ingesting the data from the building, we're creating virtual power meters for each individual piece of HVAC equipment. That also adds to the layer of, hey, how to control the system and how to optimize it when you understand every single piece of equipment consumption in real time. So that's part of the feed into the neural network to make its decision. So it's all of the strategies that were developed by smarter people than me. It's all of the AI strategies and all the predictive natures. And then it's the 4 key rules that Ross touched on into that model as well. And then it's the output.
There's another question here. So is it an interface with existing building control systems? It takes over let's go with that. Let's break this one on. It's a couple questions. We are control system agnostic. So if you got the Johnson Controls, the Trane, the Honeywell, the Siemens, we're agnostic on that. There are a couple that exist that when you go deeper into what they are, that are so much older. So obviously pneumatics. If you have pneumatics and your whole campus is pneumatics, we would disqualify it. But if you've got a district of 10 schools and 4 pneumatic and 4 DDC and then 2 you kind of don't know what you're doing with, they're not as important, we would look at the 4 that were the DDC. So BACnet over IP is what we look at. We don't necessarily look at the manufacturer until it's there's a couple oddballs that were installed in certain regions. The other thing is it takes over operation from those systems. It interacts, so we're not taking over. So it is closed loop. So it is doing an override. We do a BACnet priority 9. So we were doing 8, we dropped it to 9 because we wanted the engineering staff and facility managers to be able to override us, and we didn't want to sit at the same plane. So we put it far enough down to sit underneath them and far enough away from life safety. So it's not full control. You never lose control. It's just, it's going to look like another building engineer. BrainBox is going to be someone that's part of your team that sits underneath you, that never leaves the computer and is doing this every 5 minutes, constant, every 5 minutes, 24 hours a day. And then it's going to help you out because it's going to enable your team to get to things when you're not able to sit in front of that BMS and dig in deep. And the other thing is, are there any BACnet or Tritium BASs that it doesn't work with? We love Tritium. That hardware we showed you, we don't need that. We have software. Blake, you can talk about the Tritium a little more in depth.
Yeah, no, I think it's a good question. So we have a qualification process that I'm part of, is to review the system requirements and make sure that we have compatibility. So for example, for Tritium, yeah, we love it. Tritium does a really good job of translating native proprietary communication protocols into BACnet. And as long as it's translated and we can write to the points we need, qualified. Older BACnet systems, the first generation, could be locked down from a BACnet perspective, and sometimes we can't write to the points we need. So we definitely do a vetting and a qualification process that obviously me and Ross will work with your teams to define and make sure that the buildings will qualify.
These have all been great questions, by the way. You guys are winning as far as the best questions answered in a webinar year to date. And there's quite a few of them, which we really like. The other thing that we didn't mention is that when we do our onboarding process with the facilities or with the buildings and the customer, we ping everything. We let them know if we see something that needs to be addressed. We had a building recently in Oklahoma where someone had pinned a VAV box open. They had no idea. We're like, hey, could you go check this? Could you go release it? Because we couldn't get some control there. But we're also taking the data and we're putting it in a haystack for you so that you're going to have a clean set of tagging of the names of all your equipment as well. We do that globally. So everything that we are involved in, we've haystacked everybody's data, the new norm, the uniform. So if you've got some systems that do qualify and it's kind of dirty and mess, we're going to clean it up for you for the nomenclature into a haystack tagging system. I don't know if anyone here is using that already. Sometimes that comes with new buildings, but that's one of the things we do up front with our onboarding team.
Ross, did you want to mention the 24/7 monitoring?
Oh, yes. So there are two monitoring groups within the BrainBox organization. So we are out of Montreal, Canada, which is a hub for artificial intelligence engineers and education. Our secondary monitoring team is in Dublin, Ireland, because we are global on 5 continents. So these teams are managing the monitoring side of all of our edge devices or Tritium installations, so all the AI, because the AI is studying patterns all the time. When there is a flag that comes up, they dig into it. Either it's something that's just simple that we address on our side, or based on how we've structured it with our customer, we let you know. So you don't need to be sitting at the BMS all the time. The AI, there's monitoring that's happening constantly as well. You know, while it's interacting and learning and adjusting, there's a monitoring aspect that's happening as well in correlation with it. So our teams are there. So when we do deploy, it's not like, oh, never see you again. We're with you throughout the whole time. It's pretty exciting to know that there's something studying patterns that we can't see that will let you know about something, because it will catch a window being held open because the temperature will change and now I can't do it anymore. It's not going to say the window's open, but it's going to send you to the space and it's going to be obvious. The other thing it's compliant for procurement on a national co-op. That's also exciting. That was news that happened in March with the TIPS cooperative. So this is something now that is, use the word kosher for procurement. I think y'all have all been there on wanting to get something and waiting 18 months to get it because you went through a very fun and long RFP process. This is an offering that is offered through the TIPS cooperative agreement now. That happened at the end of March. But we're excited about that because we like schools. We like the K through 12 and the higher education market. So when you ask us, when we have meetings, where are you deployed? Well, we had the procurement thorn in the United States going on for quite a while during a pandemic. So the conversations drastically increased since the cooperative was announced. Here's another question. Do you need to work with existing BAS OEM support for the interface? Blake, I'm just going to punt it right to you. Let you just go first.
No, we don't. But I preference that is that we do need to work together as a team for the customers. So typically, we involve or bring in, if you have a really good relationship with your controls integrator, to make sure that they're aware of what we're doing and they don't just unplug our box. So But there is a education portion from our end to explain to them what they're doing, make sure that they're comfortable with it. And then we really do need to have their support sometimes. So if a sensor fails and we see that, you know, they're going to have to replace it, or the customer is going to have to replace it. So it's a mutual benefit for the whole team.
I see Marcia there over in Wiley just going, I can't wait, because I'm in Fort Worth, Marcia. So like, I'm not far from you.
Okay, I think we're done with the group questions. Glenn, you can ask Ross that.
It's one less decision I have to make a day, Glenn. That's why.
So I'm going to go ahead and open up the breakout rooms, and we're going to come back together. I think I have everyone evenly dispersed, so we'll see you in a bit.
I didn't see you pop in creeping on us this time.
I didn't. I thought someone might call me out on that.
I wanted to do it. Somebody else did.
No,
I figured
bye.
Chris would.
They must all be in deep conversation like we were.
They're going to be sent back whether they like it or not. So does anyone want to share what you guys discussed in your groups, or did you have an aha moment or something like that? If you want to unmute yourself and share, you're welcome to do that. Nobody?
We just had some interesting questions about how they use the utility data and how these virtual meters work and that sort of thing. You know, that was a question. I've spoken with these folks who are very impressed by their product, and so that was something that I hadn't gotten answered before. That I think we got a better idea of how it works, how they're going to use the utility data that's coming directly from I'm putting in those in all of our switchgear and our new installations. We're putting those modules where we can pull that information into the building automation system, but then how their virtual meters work was a question I had as well, and they had a good explanation for it. So.
Anybody else? Such intriguing conversation, you guys can't even share it. Okay. So I forgot to do this, and usually I do it and I forgot, but I threw them out there to you through the chat box. So if you guys saw them, hopefully you were able to talk about some of your sustainability and energy efficiency goals. Real Term and Brain Boxes had asked those to be the questions, so that, because it's good to kind of gauge what are, you know, the public entities, what are you actually looking for? So I apologize for that. Good thing Ross had alluded to it already. So our upcoming meetings are, we have one June 3rd. It's the DFW in-person meeting, but that will be hybrid. I'll share the link like I did from last week's GCC meeting. And if you guys ever miss a meeting, as long as it's hybrid and or virtual, I am putting it on the website. So you'll have some form of access to it if you want to watch the presentation. The next virtual chapter meeting will be June 23rd. With Fortune Energy, and we're going to talk about AI again, probably with Brainbox, go a little bit deeper into the conversation. So that will be good to continue the conversation about this type of technology. So before I move on, and I should have asked this, Ross or Mark or Megan, do you guys have anything that you want to say to final thoughts on your end?
Oh, we just love this. This is my favorite group. When talking about the future virtual meeting, I'll bring some runtime, some visuals that some people that have seen, that have met with us, where you can actually visually see the AI make an impact on fan speeds and heater and stuff like that. We've got quite a bit of visuals to show you of how it operates. But I enjoy this group. I enjoyed the event out in Sonora. Just look forward to helping out. So if you guys have questions or you want to go deeper with your group or your entity, your district, reach out to one of us. We'll go down the weeds with you and show you how this works. And if you wanted to implement in a piece of your district and try it and see what it looks like financially, and it's tailored to you. That's the biggest part about it being compliant. It's tailored to you. And Glenn's got access. He's seen the financials. If you wanted to ask him, because he's gone, we've 3 meetings with him to go deeper, because we want you to feel comfortable, right? This is not like, oh, here it is, buy it. We want you to understand it and be your whole team comfortable with it, because it is something that's very new. So if you've got questions, you want to set up future meetings, we're here for you. We'll make it happen virtually. If you're local, you want to lunch and learn, you call the shots. I'm done.
Absolutely. Yeah. Thank you. Thank you, Ross. Appreciate it. I just want to say thank you to everybody who attended today. And like Ross said, feel free, reach out. If you have any questions, we'll definitely follow up with, thank you email and provide our contact information, all that good jazz. So, but thank you very much for your time today. Ashley, thank you for everything and getting this all organized. And we look forward to hopefully seeing everybody at the conference here coming up relatively quickly. So yes. Thank you very much. Appreciate it.
So as always, stay connected with us through our social media. And if you have any comments, things you want to share with us, just let us know. We have a on our rotator on our website. You can fill that out, fill out a survey. And so for the conference winners, for those who have renewed their membership, they are Alvin Dorsman with Wichita Falls ISD and Chris Armacost, which they were with Hitchcock ISD, which they were not on the call today, but we will be getting to them. So if you guys want to try to win a free conference, either do where all the places Timo will go or renew your membership. That is all we have for you guys today. So I hope you guys got a lot out of it. We will, if you're able to join us for the hybrid DFW meeting next week, great. If you're going to be there in person, I will see you there.
Hey, real quick, Ashley, I'm going to send a document out to you to distribute. It's the frequently asked questions that we've got globally. It's a long list that is very helpful. It's a great one, because a lot of things that you may have questions later are going to be on there. So I'll send that to you. So
what I will share, as always, these recordings will be on the website. So I will also put the presentation. So if that's part of if you send me I have the presentation from Clay Shoot. It's very similar, but if it changed any, just send me that with it.
Okay, sounds good.
So that's all we have for you guys. Thank you so much.
Thanks, everyone.
Thank you.
Thank you.
Thank you.
Bye. Thanks.